Okay, let's take a look at the second example here. So what did you come up with in terms of amplitude and period? What's the amplitude? 1/4. And what is the period this time? 2 pi over 3. Okay, we know we're going to be working in scale factors of pi over 6. We know that our phase shift is going to be pi over 6 units left, and the vertical displacement is going to be 2 units up. Okay, again, we're working with cosine of x here instead of theta, cosine of x. So instead of drawing the original, actually I will draw the original graph just as a review for you guys. I want to set up my domain accordingly, so negative 2 pi to 2 pi. I'm going up in scale factors of pi over 6, so I want to make sure that I'm moving left and right of the scale factors of pi over 6, so I want to make sure that that's identified clearly on my graph. So let me go up by pi over 6. So you got 1, 2, 3, 4, 5, 6, that will be pi. 1, 2, 3, 4, 5, 6, 2 pi. Now what might happen sometimes is you'll notice that 2 pi over 3 is our period and pi over 6 is our scale factor. Sometimes what might happen is based on the scale factor, we might not be able to properly draw a full graph in that period. So what we may have to do is we may have to change our scale factor into a common denominator of the phase shift and the period. Right? So say for example the phase shift is pi over 6 and the period was 2 pi over 5. Well, 2 pi over 5 and pi over 6 are not going to match up. I can't fit enough pi over 6 to get to 2 pi over 5. So I would have made my subdivision as a GCF, or the lowest common denominator of pi over 6 and 2 pi over 5, which would have been pi over 30. Right? So it would have gone up by scale factors of pi over 30, just so I can fit both of them evenly in there. Right? And we'll come across a problem like that later on. But for now, it works. Similarly, in the negative direction, we got 1, 2, 3, 4, 5, 6. So negative pi. 1, 2, 3, 4, 5, 6, negative 2 pi. Alright, let's start off with the original graph. I'll say this is going to be 1, so 1, 2, 3, this will be 1, this will be negative 1. Because then I'm going to be compressing it eventually, I'll make my scale factor a bit bigger there. The original graph would have looked like this. The cosine function starts at 0, 1. It ends at 2 pi 1. Okay. This is something you'll need to know out of memory, be able to come up with this graph out of memory. The general shape of a cosine function looks like this. It starts at the maximum, ends at the maximum. In between, it's going to be at the minimum. So at pi, it's going to be at the minimum of negative 1. And then in between the maximum and the minimum at pi over 2, it's going to be at 0. The reason being is because cosine of pi over 2 is 0. Cosine of 3 pi over 2 is also 0. And then cosine of pi is negative 1, cosine of 2 pi is 1. When you connect the dots, you end up with this graph right here. This is the original graph. Same thing in the negative direction. Negative 2 pi will be the maximum. Negative pi will be the minimum. Negative pi over 2 will be the 0. Negative 3 pi over 2 will be the 0. Right, this is our original function, y equals cosine of x. Okay, now we're going to take this function and we're going to go ahead and try and transform it. So the first things that I'm going to do together are these two things together. I'm going to do the amplitude and the period together in one go. So the new amplitude is 1/4 and the new period is 2 pi over 3. So let me see where that's going to end up being. Notice each scale factor I'm going up by is pi over 6. So 2 pi over 3 is the same as 4 pi over 6. 2 pi over 3 is the same as 4 pi over 6. So that means my graph is going to start at 0 and 1/4 up here. 0 and 1/4. And it's going to end at 4 pi over 6 and 1/4. So that's 1, 2, 3, 4 pi over 6 and 1/4. It's going to end right there. In between those points, halfway through, we're going to have our minimum. Right? In between those points, right here, we're going to have the minimum. And then in between those x values, we're going to have the 0, which means there's going to be a 0 over here. And it's going to be a 0 over here. Or if you think about the normal cosine function, the normal cosine function has zeros at pi over 2 and 3 pi over 2. We've now compressed that horizontally by a factor of 1/3. So pi over 2 is going to become pi over 6. We've got a 0 at pi over 6. And 3 pi over 2 is going to become pi over 2. So we now got a 0 at pi over 2. Which is where our zeros are, at pi over 6, right here, and at pi over 2, right there. This becomes one full cycle of our function. We went from that big graph over there to this tiny graph over here as one full cycle. We can keep going because we want to fill in the domain. So again, from here, 4 boxes over, it's going to go 1, 2, 3, 4. It's going to end right here. In between, it's going to be the minimum. In between those x values is going to be the 0 and the 0 again. This graph is going to continue on like this. And then similarly, I'll do one more. So 1, 2, 3, 4. Minimum, 0 and 0. Okay, because our graph got squished by a scale factor of 1/3, instead of fitting in one full cycle, we can now actually fit in 3 cycles in the same period. Right? 3 full cycles in the same period. Similar thing in the negative direction. I'll just mark all the minimums and zeros, maximums and zeros, and I'll actually end up getting this graph right here. Okay, this is the graph of y equals 1/4 cosine 3x. I've only applied the amplitude and the period. I haven't applied any phase shift or vertical displacement yet. Now I can go ahead and apply the vertical displacement and phase shift. Each point is moving pi over 6 to the left, 2 units up. So pick each of those points. Pi over 6 is one box. So one box to the left, 2 units up. Now 2 units up is going to be a bit tricky because I have adjusted my scale accordingly, right? Shouldn't have done that. Shouldn't have adjusted my scale like that. Should have kept a little bit more space in it. So 4 boxes. It's gonna need 1, 2, 3, 4 more boxes up, 2 up. Yeah. Should have redone that one. Let's see what we're gonna do here. How can we fix this? Here, we're gonna do a quick fix by doing a little bit of erasing here. Okay, follow along, and we'll try and fix this here. I'm gonna erase the original function. Okay, original function's gone. Right? The maximum right now is at 1/4 and negative 1/4. I'm just going to cut the maximum minimum in half. So the maximum points, so we'll erase this one here as well. Just leave the points on there and I'll show you how to adjust the points. We're just going to squish it by scale factor 1/2 even more. The zeros stay where they are. Just take each point and just cut it in half. So it was there, it's going to end up down over there. Take each maximum and minimum, cut it in half. The zeros can stay where they are. I wish I had compensated for this earlier. This is what happens when you don't think ahead in terms of your scale factor. So it'll actually look something like this, just squished in horizontally a little bit more. Alright, and I can now properly label my scale here, so I can actually make those transformations. 1, 2, 3, 4, 5, 6. This was pi, 2 pi. Then this is going to be 1. This is going to be 1, 2, 3, -1, -2. Right, so now it's got an amplitude of 1/4, and it's got a period of 4 pi over 6, or 2 pi over 3. Are we okay with making that adjustment? We're just switching the maximums from one box to half a box. Right, minimums from -1 box to half a box, everything else stays the same. So this is the graph of y equals 1/4 cosine of 3x. We need to move it pi over 6 to the left and 2 units up. Now we can start with some of the points. Take each point pi over 6 to the left, so one box to the left, and then 2 units up. 2 units up is basically going to be, how many boxes, 2 units? So 1, 2, 3, 4 boxes up. So pi over 6 to the left, so 4 boxes up. So 1, 2, 3, 4. It's going to end up right here. Take the 0, move 1 box over, 4 boxes up. Take the minimum, move 1 box over, 4 boxes up. 1, 2, 3, 4. Take the next 0, 1 box over, 4 boxes up. Take the next maximum, 1 box over, 4 boxes up. And soon you will get the hang of it, that you know what, there's a continuous pattern. The next 0 is going to be over here, the next minimum is going to be here, the next 0 is going to be here, the maximum is going to be here, 0 is going to be here, minimum here, 0, maximum 0, and we stop at 2 pi. And then similarly in the negative direction, 0, minimum, 0, maximum, 0, minimum, 0, maximum, 0, minimum, 0. So that's the graph that we end up with. That's going to be the graph of our transformed function y equals 1/4 cosine 3x plus pi over 6 plus 2. Are we okay with that?